Hi, I'm Dr. Leonie. This is the last week for statistics. We're going to recap from the beginning until the end of this course in these few slides. Now you're going to prepare one piece of A4 paper, a calculator and a pen. Remember that around 3 weeks ago, there was a WhatsApp conversation between the boss and the staff. Boss asked the staff to find the best fertilizer to grow the spinach plant. Is it the fertilizer brand F, or is it the fertilizer brand H, fertilizer brand L, or fertilizer brand P? We might have four ways to get the answer. The first way, option A, I close my eyes and I just simply pick the best fertilizer. We have four brands of the fertilizer. Let us check in terms of accuracy and practicality. Is it accurate to get the best one? It might get 25%. Why? Because 1/4. Yeah. We close our eyes and we randomly pick. There will be chances. And how about the practicality? How much does it cost us to get this decision? 0 ringgit. That's not even 10 cents. We go for the option B. So we conduct a simple experiment. On day 10, I'm going to measure the spinach height produced by these four fertilizers. Each of the fertilizer, I have 15 pots. Fertilizer F, I have 15 pots. Fertilizer H, 15 pots. L, 15 pots. And P, 15 pots. And then I measure what is the height average for F, H, L, P. Let's check the accuracy and practicality. So the accuracy to get this conclusion is around 60%. How about the cost? Let's say each pot we need to invest 1 ringgit, so it costs 60 ringgit. Let's go to the option 3, whether we can make a good conclusion. On day 10, I measure spinach height of those four fertilizers, and I conducted 10,000 pots for each fertilizer. Do you think that we're going to get a very accurate result? Yes, because we are doing 10,000 pots for one fertilizer. That will be 40,000 pots. It means that it's going to cost us 40,000 ringgit. Okay, accuracy is very good, but it's not practical. Let's go to the fourth option, whether we can get the good conclusion. On day 10, I measure spinach height of those four fertilizers, each 15 pots, and then I conduct one-way ANOVA. How about accuracy? Yeah, we're going to get close to 80%. Better than the 60%, but it's lesser than 100%. How about the cost? The cost is 60 ringgit. One pot, 1 ringgit. So it's much more cheaper than the 40,000, right? And then the implied cost is the same compared to the B. A, B, C, D. Which one you choose? Obviously, we're going to pick the D one. Let's see case B. On day 10, we're just doing the 15 pots experiment. What happened to it? We are collecting the data so-called in sample size, a smaller size. What kind of story that we can tell about option B? We can just tell the story about 60 pots. That's all. No, not 40,000, not 10,000 case. We just can tell the story about 60 pods. We call this one as descriptive statistic. It happens when we are telling story about the sample. What kind of story that we can tell? We can tell the boss about the mean, the median, the mode, the standard deviation, the range, the pie chart, the bar chart, but it's about those 60 pods only. When we try to make the guessing, the conclusion, we are making the conclusion apply to 60 pods only. That's all. Let's go to the option D. On day 10, I measure spinach height of those 4 fertilizers, each 15 pods, and then I extra do the one-way ANOVA analysis. What can we get from this process? The first one, yeah, we're doing the same thing. We are collecting the sample size only. We also can tell the story the same way as the B case. We also can tell the story same way as the B case. But now, because we are using the one-way ANOVA, we can check whether is there any differences in terms of the average height, at least for those 2 types of the fertilizers. Why we use one-way ANOVA but not t-test? Because t-test is used to compare 2 brands, 2 fertilizers only. For our case, how many fertilizers we have? We have 4 brands of fertilizers. So that's why we use one-way ANOVA. Why we are not using the chi-quest test? Because the chi-quest test needs our dependent variable is countable. And then our case, our dependent variable is measurable, the spinach height in cm. Why we are not using the correlation test? Because the correlation need to have independent variable and also dependent variable measurable. But our case, our independent variable is group and dependent variable is measurable. So we have solved for our case to determine which is the best fertilizer. Let's go to the next situation. Let's say that through one-way ANOVA and the post-hoc test, we found that the best fertilizer is fertilizer L. Why? Because fertilizer L does produce a different spinach height compared to the other 3 brands there. Our next question will be, if I put more fertilizer L, will my spinach grow much higher? We want to see the effect of our fertilizer. Which tool that we're going to use? Correlations. So, when at the end, our correlation value, let's say we obtain 0.7906, where does it fall? It falls somewhere here, close to this value. It means that we have a strong correlation between what? Between how much fertilizer and how high the spinach. It's time for you to bring out your paper and then spend around 1 minute to create this kind of template. You have the tutorial W14, name, student ID, program, FYP, title, conclusion, data, and correlation. What you need to do, you're going to design a final year project related to your program. Scope is to find the correlation between 2 numerical data. You're going to insert 5 pairs of data. Example, if you are SBF, you might do this kind of project. Does watching more minutes of food security video going to reduce the food poisoning cases in a school. If you are SPH, maybe your title, maybe, okay, you can change out the title. Does cow intakes more gram of brand Z feed, the food for the cow, will make the cow grow heavier in kg? You see, our DV, dependent variable, and our independent variable is all numerical value. If you are SBL, you might think of, oh, does intense UV light, ultraviolet light, will make my rose flower grow taller? And if you are SPP, maybe your title might be mushroom flour in gram added to cookies. Will it increase the sensory evaluation of acceptance? So it depends on which program you are. How are we going to fill in that tutorial 14? This is one of the example. Okay, you have your name right down there. You have your student ID, your program, your title. You can think about suitable to your program title. Let's say for this case, you want to check the effect of fertilizer L on spinach growth. The effect. Will it give some effect? More fertilizer, higher growth? Can we so-called prove it? And then you're going to write down the conclusion, but that will be after you do the coloration calculation. For this case, there is no relationship between amount of fertilizer L and spinach growth. Okay, so you just self-create your own data. For this case, we have the spinach height, and then we have the fertilizer L. So fertilizer L will be the independent variable, and then the height will be dependent variable. So we are pairing our data. Just self-design 5 pair of the data there, and then you start to use the formula, this formula, to find the correlation value there, and then use the correlation table, the strength of it, and get the conclusion for the sample size case. This is a strong correlation, but we need to conduct a simple inferential statistics to determine, in case we are doing 10,000 case, will we get the same trend there? Is it still a strong correlation? Then we need to use the R correlation test to determine it. For our case, we have total 5 pairs. 5 minus 2 will get 3. And then we will check at 0.05 significant level there. It is 0.878. We need to have a higher than 0.878 so that we can reject the null hypothesis. But for this case, we fail to reject it. So at the end, we'll say that based on 5-point experiment, there is no significant relationship between the fertilizer L weight and the spinach height. Means that our conclusion at the end will be there is no relationship between amount of fertilizer L and the spinach growth. Okay, we'll go to the last slide. What are you going to do for this last week? There will be 3 things. The first one, tutorial. This tutorial, just now, the tutorial W14, complete it, and then you submit it before 10:30 AM today. Which link? This is the link. The project. Leader going to submit it today, 5 PM. Which link? This link. And the most critical one is the test 2, 10%. You have 1 hour from now to do the test 2. You need to submit today by 9:10 a.m. Extra 10 minutes because you watched the YouTube video. Which link? This link here. Go to this link. There are total of 10 questions. Okay, good luck, and if you have anything, email me as soon as possible. Bye.